Good morning, students. Today's our topic is formula. The symbolic representation. Symbolic representation of molecule is known as formula. Molecular formula, also known as chemical formula. The other name of formula is molecular formula is known as chemical formula. A molecule of an element may contain one or more atoms. It may contain one or it may be more than one atom. For example, we can take hydrogen, oxygen, nitrogen, chlorine, etc. Molecule of element like hydrogen, oxygen contains two atoms and written is it has two atoms of hydrogen, two atoms of oxygen. Same here, but sometime molecules containing different atoms united in a certain fixed ratio. Certain fixed ratio. Just we take the example of H2O. Here is two atoms of hydrogen and one atom of oxygen. In which ratio? 2:1. 2 for hydrogen and 1 for oxygen. In which ratio? 2:1. Take one more example, NH4Cl. It is known as ammonium chloride. Here is two different atoms of two different elements, but here there are atoms of three elements. Nitrogen, one atom of nitrogen, four atoms of hydrogen and one atom of chlorine. In which ratio? Nitrogen is 1:4:1. The molecule of ammonium chloride has three elements in 1:4:1, and the atom of nitrogen is 1, atom of hydrogen is 4, and atom of chlorine is 4. We can take another example, Na2CO3, MgSO4. So many examples we can give here. But what is the significance of molecular formula? The question rises this: what is the significance of molecular formula? It gives information about molecules and molecular mass. It gives information about molecule and molecular mass. It represents both molecule and molecular mass. What is molecule and molecular mass? It means we take here example CO2, one atom of carbon and two atoms of oxygen. In which ratio? 2:1. The molecular mass for carbon is 12, and the atom is 1, so we multiply it by 1. In oxygen there is 2 atoms, so multiply it by 2, and the molecular mass of oxygen is 16. 12 plus 32 equal to 44. It means it gives the information about molecules and molecular mass. We can take one more example, H2O. 2 atoms of hydrogen, and molecular mass of hydrogen is 1, and molecular mass of oxygen is 16. 2 plus 16 equal to 18. It means one molecule of hydrogen has the molecular mass 18. This gives the information about molecules and molecular mass. Now, the respective number of different atoms present in one molecule of a compound. To explain this, take example of ammonium chloride, NH4Cl. In this molecule of ammonium chloride, and it has 1 atom of hydrogen, 1 atom of nitrogen, and 4 atom of hydrogen, and 1 atom of chlorine. This gives the information about the molecules present in atoms present in a molecule. The ratio of the respective masses of the element present in the compound. This is all about the formula and significance of formula. Now the next topic is radical. The molecules of a compound is usually made up of 2 parts, KCl. It is when splitting KCl, it gives calcium plus ion and chlorine minus ion. It gives 2 parts. One part is positive and another part is negative. So, other radicals, similarly magnesium sulfate, here is magnesium sulfate. 2 parts of magnesium sulfate are Mg plus 2 and SO4 minus 2. One part and another part. These are called a radical is an atom or a group of atom. Is an atom and group of atom. So sulfur and oxygen. Group of atom of the same or different element that behaves as a single unit. They behave as a single unit. This is the single unit. They behave as a single unit with a positive or negative charge. Positive or negative charge. So we can define the radical in this way. A radical is an atom or a group of atoms of the same or different elements that behaves as a single unit with a positive or negative charges. Now here are 2 types of radical: simple radical and compound radical. These are simple radical because they are having only one kind of atom at their positive and negative charge. But in case of sulfate, it has 2 different kinds of atom in this sulfate. So this type of radicals are known as compound radicals. In this, when it is an atom only A radical is called simple radical when it is an atom of only like sodium and magnesium +2. They do not have any other atom in them. So they are magnesium +2, sodium +1, calcium +1. They are having only one kind of atom in this. But here is a SO4 -2, carbonate -2, NO3 -2. These are having two different kinds of atom in them, so they are known as compound radical. An acid reacts with a base. Reaction of acid and base. It gives salt and water. When acid reacts with base, it gives salt and water. HCl plus KOH. It gives KCl plus H2O. Right? Now, in this reaction, K reacts with chlorine and this H and OH react and form H2O. In the formation of potassium chloride, the potassium radical has been contributed by the base potassium hydroxide. Chloride react with calcium and chloride react with potassium and gives potassium chloride and is therefore called basic radical. This potassium comes from the base KOH. So these are known as basic radical. It is known as basic radical. While the chloride radical has been contributed by hydrochloric acid and is therefore known as acid radical. This chloride comes from HCl is a acid and KOH is a base. Cl comes from the acid. Cl comes from the acid part, so it is known as acidic radical. But in case of this potassium comes from this OH base, so it is known as basic radical. I explain it again. When acid and base react, it forms salt and water. KCl is a salt and water. Now here is a two terms is described. One is acid radical and other is basic radical. This Cl comes from the acid part. Cl comes from the acid part. Due to this is known as acidic radical. And this K comes from the base. So this K known as basic radical. When a salt is dissolved in a water, it splits into constituents radical. When some salt is dissolved in water, they split into plus and minus, positive and negative charge radical. Formed to carry positive charge, so are termed as electropositive radicals. This positively charged radicals are known as electropositive radical, and they are also known as cation. Same here, when salt dissolved in a water, it split into positive and negative charge. The negatively charged radical is known as negative radical or anion. Here is two terms, basic radical and acid radical. Basic radicals are known as electropositive radicals, and the other name of electropositive radical is cation. Same here, the negatively charged radicals are known as electronegative radical or anion. Radicals have their own combining power. They have their own combining power, and this combining power is known as its valency. The combining power is known as valency, and it is according to this combining power that they form chemical formula, or due to this valency we can form a formula of a salt. Just take an example of compound ammonium carbonate. Ammonium carbonate. Ammonium carbonate. Right? The formula for ammonium carbonate is NH4 whole twice CO3. This is the formula of ammonium chloride. Now it is split in NH4 plus ion and CO3 minus ion. The valency of carbonate is 2 minus 2. It means it combined with the two atoms of ammonium and complete its valency. And here the ammonium has the one valency, so it reacts with only one atom of carbonate. Same here, this is the basic radical and it is acid radical. Look at the table which is given on your page number 6. Here are different kinds of electropositive and electronegatively charged radical. There are different kinds of electropositive and negative ions. Monoelectrovalent. Mono means one, having plus one charge. Mono means plus one charge ion. Divalent, having plus two charge. Trivalent, having plus three charge, and tetravalent, plus four charge. Same as the electronegatively charged ion. Mono, this is electro radical. Same here. Mono means minus one charge, monovalent. Divalent, minus two charge, having minus two charge. Trivalent, having minus three charge, and tetravalent, having minus four charge. Here are different ions which are represent the different kinds of electronegative or electropositive charge radical. You have to learn all the ions with their valency. The next topic is writing chemical formula. How to write chemical formula. Writing chemical formula. To write a chemical formula, the method is known as crisscross method. The method crisscross method. To write chemical formula, we use crisscross method. First, we have to write the symbol side by side. Basic radical is written first and then acidic radical. First, we have to take magnesium chloride. The example is magnesium chloride. Magnesium chloride. Write the symbol of magnesium. It is Mg. And the symbol of chlorine is Cl. Look at the table. This is first basic radical. Look at the valency of magnesium. It is +2. It is divalent electropositive. Then look at the electronegative charge chlorine. What is the valency of chlorine? It is -1. Now what you have to do? Forget this charge and write this valency at the bottom of their symbol. At the bottom of their symbol. 2 here and 1 here. Now cross this valency. 2 take at the bottom of the chlorine and 1 at the bottom of magnesium. Now what you have to do? Put Mg as 1 and chlorine as 2. MgCl2. This is the formula, this is the steps from which we can write a chemical formula for a substance. Have a look. Once again, the method from which we write chemical formula is crisscross method. In this method, first we have to write the name of a substance, name of a compound. Magnesium chloride. Then write the symbol of magnesium and symbol of chlorine. Put their valency at the top of their symbol. Then what we have to do? Forget this charge and put them at the bottom of the symbol. Take write 2 at the bottom of magnesium and 1 at the bottom of chlorine. And now cross them. Take 2 at the side of chlorine and take 1 at the side of magnesium. Now what we have to do? Magnesium represent as 1 and chlorine represent as 2. And we can write the formula for magnesium chloride. This is the whole step to write a chemical formula. Take one more example. Calcium oxide. Calcium oxide. Write the symbol of calcium. It is Ca. And oxide, it formed by the oxygen, so we write here O. Put their valency at the top. You can see the valency in the given table. Calcium is a divalent electropositive and oxygen has divalent electronegative ion. Now what we have to do? Put their valency at the bottom of them and cross them. 2 and 2. Divide by 2 because we can change it into simplest form. Write it in this way. Now what we have to do? Calcium Ca2, oxygen O2. Cut this, divide this 2 by 2. And this will cut down and we get the formula of calcium oxide. This is the chemical formula for calcium oxide. Can we take one more example? Aluminium hydroxide. Aluminium hydroxide. Aluminium. Write the symbol of aluminium and the symbol of hydroxide. Put their valency. Write their valency at the bottom. Cross them. AlOH whole thrice. If the negatively charged ion having more than one atom, here is oxygen and hydrogen, to represent this compound radical we use bracket. Write the interchange valency number of the lowers right and radical if the radical is a group of atom and has a valency number more than 1. If it is valency is more than 1, enclose it within bracket. This is the formula of aluminium hydroxide. From this we can write many more formulas. Here is a table of important formula of different salt and different compound. You have a look at this. We will take another topic in our next class. Have a good day.